Hi everyone, thank you so much for attending my talk. I know it's a virtual event, but it's always great to be able to share some knowledge, whether it be through my blog posts or through a conference like this. And when Ben reached out to me to speak at NahamCon, it was just a good opportunity for me to share a really cool bug that I found recently in Zoom, the Zoom application. And I'm also really grateful to the Zoom security team for approving disclosure so that we can talk about this and learn a lot from this bug. So the title of this talk is called I Hope This Sticks, Analyzing Clipboard Event Listeners for XSS. And you might think, oh, Clipboard Event Listeners that copy and paste, is this a copy and paste XSS? Well, kind of, but not the kind that you're thinking of. And you'll find out more when I go through this talk. So to quickly introduce myself, I go by spaceraccoon as my hacker handle. I'm on HackerOne on Twitter, and I have a blog as well. So for the blog, I'm actually going to post a blog post about this talk later on after this talk. So if you want to learn more, just follow up and catch up on stuff that you might have missed during this talk, just go to my blog at spaceraccoon.dev. So for today's talk, I hope that you take away three things, right? I'm going to be talking about a bug that I found, but I think there are some important lessons that you can take away from this talk. The first is automated JavaScript analysis. So there are a lot of tools these days that help you run code scans. For example, CodeQL, Snyk, SamGrep. And while these tools might be able to kind of find possible vulnerabilities, as a penetration tester, you're going to use these tools very differently from, say, a developer that's using them in a continuous integration workflow, right? And you're going to have to approach these results that are coming out from the SAST or code scanning tool with a bit more perspective and use it in a way that is actually useful for you to find real bugs instead of fighting with false positives. So I'll be going through that this talk. The second is to really introduce the MDM web docs as well as the W3C standards docs that are online for you. And the reason why I want to share this is because while we might think we know all about XSS or JavaScript, the field of web APIs and the HTML standard is always growing, it's always changing. And it's great that these documentation allows you to really understand in detail what's going on under the hood, right? So rather than trying to feel your way around, say, TypeScript or for specific data types, the MDM web docs is a fantastic tool for you to understand this and to build your payloads efficiently. And the third kind of takeaway I hope you get from this talk is exotic event handlers, right? As I mentioned, web APIs is constantly growing. The JavaScript web API, there are new functions you can call, there are new tools you can use. So you can use stuff like calling background handlers, calling stuff like opening a webcam. And these web APIs are constantly being added onto and adding new attack surface for a penetration tester. So it's really important that you keep an eye out for this. I know Gareth Hayes at Portsmouth does fantastic research on new event handlers all the time, but you can also take this on, whether it be by reading the MDM docs or just trying to build your own payload. And the background to this talk is that I'm really interested in how the border between web and native continues to blur in our applications and application security today, right? Back in the olden days, we had something called Rhino.js, which is a Java, a Java engine for JavaScript, right? And then, not too long ago, but still fairly long ago, we had Node.js, right, through the V8 engine, and that really changed the way that people use JavaScript. Rather than just being in a browser or the client side, it's now been moved to the server side as well. And then we have stuff like Electron, WebAssembly, and Hermes. So Hermes is a new JavaScript engine released by Meta specifically for React Native, right? So these are all new ways in which the web or web APIs and JavaScript are being brought into different platforms from mobile to native to desktop. And it makes it a lot more interesting because in the past, when you were exploiting native applications or desktop applications, you tend to look at for memory corruption or very specific native only vulnerabilities. Whereas now, because you have stuff like Electron and WebAssembly and Hermes, you can kind of blur the line and find web vulnerabilities or even chain web vulnerabilities with memory vulnerabilities or desktop vulnerabilities. And a big part of this is because web APIs and standards are always growing in complexity. So if we only look at, say, UI events, right, stuff that affects the UI of a web page, it's still being constantly updated, the last being 13 September 2022. And, there's just so much complexity there. This talk is about a very specific handler, the Clipboard, right? And we look at what kind of interfaces are available to the Clipboard, just the amount of support and the variety of data types that you can put into a Clipboard. It really just is a fantastic attack surface. So it's something that I'm always interested in, something I'm always trying to learn more about, because instead of just trying to pop alert, there's so many other things that you can do with JavaScript exploits in the web. So looking at the target itself, the target I was looking at was called Zoom Whiteboard, and this is a feature built in most of the Zoom clients, from web to desktop to mobile, right? And it functions kind of like a canvas, a shared canvas where you can collaborate, you can work on sticky notes, you can add comments, you can add diagrams, you can add text boxes. So think of it as like a digital whiteboard, right, that you can work on during a meeting to discuss ideas. And the interesting thing was that the Zoom whiteboard actually had the same implementation on both the web and desktop clients, which is that it used React Native. And the thing about React Native is that because it's available on the web, you're able to pull the source code very easily, and that helps you give a better understanding of what's working on the desktop client itself, rather than trying to go through the whole hassle of reverse engineering the desktop client. And so the thing about Whiteboard was that on the web, it actually included the source map file. So typically on the web, say for example, if you load a resource that ends with .js, you can try adding .map, right? Or you might automatically try to load that. And what a source map does is that it allows a browser or you to unpack the packed JavaScript back into the original project folder with the original source code. So rather than fighting with minified code or obfuscated code, you just get the original source code. And there are a lot of articles out there about how you can convert a source map file back into the original JavaScript. But I have a tool online on my GitHub called Webpack Exploder. It's just a fun interface for you to just upload the Webpack, the source map, and this will give you back the original zip file of the project. So you can check it out and use that if you can, but you can also run it as a command line tool if you look at the source code. So I unpacked the source map, and that gave me the project folder of Zoom Whiteboard. And if you look at the files and the folders available, it can tell you a lot of things, right? So you can look at the .tsx extension that just tells you that it's using TypeScript React, right? If you dig a bit more into, say, store folder, that is actually a Redux store that's used with React. You look at a proto-C folder, then you understand that there's some protobuf going on that allows for communication between the client and the server. So it's using protobuf in the background. And just by looking through the source code, skimming through it, I could understand what was the WebSocket being used, what third-party dependencies are being used. And this gives me a general idea of the structure and the architecture of Zoom Whiteboard. And so when I'm faced with a huge project folder like this, I usually like to run CodeQL for quick wins, right? CodeQL is this code scanning tool that allows you to do multi-file analysis, and usually it does have some built-in default rules, such as catching cross-site scripting. And the thing is that, even though you might seem to catch these cross-site scripting vulnerabilities, you might get some false positives, and this was the case here, right? Even though I identified what might have been cross-site scripting, these were actually false positives. But this was not a lost cause, because when you analyze these alerts through CodeQL, you get a better understanding of the flow of user data, where the user inputs come from, and where these inputs are being converted into output, right? And this gives me a broad overview of where are the typical event handlers happening, where is user input coming into Zoom Whiteboard. So this was a case here where I identified event listener for the paste event. So basically when someone pastes into the event, and it was passed into something called prepare data, a function called prepare data. And this is where it got interesting, because I saw that it was trying to get MIME type text HTML data from your clipboard. So I didn't quite understand, how it was doing this. How does it understand whether it's a HTML or text data? And so I had to go on to the MDM web docs, which explain the data structures and usage. So for example, you can actually set the data in your clipboard using JavaScript, and you can specify the format of that data. So it could be text or plain text or HTML, which was the case that we saw in the previous function. And you dive a little deeper into what can actually be in your clipboard. You see something really interesting. So on the right column, you can see the box that I highlighted. You can drag text, you can have links, you can have HTML and XML, dragging images, nodes. So this is for the drag and drop interface, right? But it really adds something else to your analysis here, because then you're thinking, okay, does this help me bypass certain restrictions in the code? Does this help me add certain payloads that the developer might not have anticipated? And you keep digging, you see something interesting here, right? You can have a text plain data type, MIME type. You can have images. But then for Mozilla specifically, it has an application X Mozilla file type for an image located on the disk. And I didn't dig further into this, but this is really an interesting angle of research. I think, if you start looking into specific proprietary data types for these web APIs, you can actually find a ton of interesting things. So this was interesting to me, but that was kind of at the extent of my analysis of the source. Because after analyzing the source, I wanted to then track the flow of the user data from the source to the sink, right? And so this brought me to the paste wrapper function, right? So after you paste something, it's going to read your clipboard data into a global variable using this.read. And then after it's been read, this global variable is going to be used in the page.paste function, where it's basically added to your whiteboard as HTML. So this is kind of a high level overview. You really want to dig into, okay, so exactly what is happening? How is my clipboard data being passed into a Zoom whiteboard object, and how is that whiteboard object being passed into HTML on the page itself? So on the right here, you see an example of passing an image from your clipboard data. So you'll create an image, and you see that it returns an object literal, where it has the wire type WB object type image. So that's really interesting. So for me, how do I understand what's going on where it reads your clipboard data, and then it understands that, oh, you're trying to paste an image, or maybe you're trying to paste say a diagram, or maybe you're trying to paste rich text, in which case it would just paste a text box on your whiteboard. So this brought me to the get ZDC copy objects function, and we see that it then passes, it just takes your text from your clipboard, and then it passes it to get ZDC copy objects from a HTML string. And then this function itself is this massive, well, not really massive, but fairly complex function that I'm not going to go through exactly here, but I'm going to summarize it in this slide here. And basically, by following the flow of the JavaScript code and analyzing and finally understanding exactly what was going on, this was what was going on, right? It first takes your clipboard data, so it's, at the end of the day, it's still text, right? But it passes it as HTML. So it expects some kind of HTML string in your clipboard. And once it has passed your HTML string into an actual document, virtual document, it's going to look for the first span element in your HTML and extract the value of the data meta attribute from that span element. And within the data meta attribute, it's going to look for a specific regex. So it looks like this is ZDC data, and it kind of like, it looks like a comment, but it's not really a comment. It's just a custom proprietary string that Zoom uses to identify this. It's going to base64 decode the inner match of this regex, and it's going to URI decode the base64 decoded data. So this might be a bit hard to visualize. So here's a slide that explains it, right? On the left is what is on your clipboard at the time of the pasting. And on the right is what Zoom Whiteboard passes it into. And as you can see, it basically passes that into various, like a custom object that might match something that is being pasted into the Zoom Whiteboard itself. So this object that is output will then be converted into a HTML or a React component that is added to your page. And we'll go into more detail about how that happens later. But now that I understand, from source to kind of halfway to the sink, what's happening, I now needed to find a vulnerable sink, right? So as I shared earlier, there are various types that you can add to your whiteboard. You can add like a shape, you can add a line, you can add a text, a rich text, you can add maybe a sticky note, image, or comment. And while using Zoom Whiteboard, I noticed an interesting behavior where entering, say, B, the bold HTML tag on comments and sticky notes and rich text, created bold text after saving the document. But XSS payloads like script or any other kind of value didn't work, right? So this was interesting. There was some kind of sanitization going on. And after analyzing the code further, I realized that for specific whiteboard objects such as the sticky note or the comment or the rich text, these were editable texts. And what Zoom Whiteboard was using was that it was using the React content editable package. And before it passes the value of that, the sticky note or the comment to content editable to the HTML parameter, it actually runs the sanitize HTML function on it. And why was this important? Well, this is because the content editable package simply sets the HTML property using dangerously set inner HTML. So if you have any kind of HTML value or string in there, it's just going to paste it as is, which is why Zoom Whiteboard needed to sanitize it ahead of time. So looking at sanitized HTML, I found out that it was using DOM Purify, which is with pretty sane settings, configurations. So there wasn't really a way to bypass that unless I really wanted to fuzz it and find a bypass for DOM Purify. But after checking all the implementations of content editable, I realized that sticky notes used content editable, but it didn't use the sanitize HTML function. Instead, it used a different function called convert to text, right? And on the right, you see kind of the function convert to text. So if you look at the full function of convert to text, you might spot a mistake, right? So just to go through what it does, it basically looks for different values using a regex in your string, and then it replaces, for example, BR or a division or a paragraph with a new line, which is kind of visually that looks the same as what the HTML tag would have done. But for any other HTML tag between two angle brackets, it's just going to remove them entirely. So even if you have, say, a division tag with some kind of attribute that allows you to execute XSS, since it doesn't match that division regex, it's going to match the final regex, then it's going to be replaced and removed and sanitized. So it looks like a pretty bulletproof regex. But there is a mistake here. And so let's see if you can spot the mistake. I'm going to give you a couple seconds to think about it. Maybe you can put it in the chat. Right, so hopefully some of you have spotted the mistake. The regex was actually missing the multi-line flag. And so what do I mean by that? If you look at the regex, at the end of it, the slash, it adds stuff like GI. So G is the global flag, right? So it basically doesn't just replace one instance if it finds it in the string, but it replaces all instances, right? But it's missing the M flag. And what does the M flag do? The M flag actually allows the regex to run across new lines. And so if you think about it, then the following string here, where we have the new line character in the string, is going to be, the regex can't work across these new lines, right? So this allows you to inject XSS payload that isn't sanitized, right? So this entire string here is just not going to be sanitized. It's actually just going to be accepted as is with the new line and all, but the new line is still valid HTML, which allows you to inject your XSS payload. So with that, I wrote a POC to generate the payload and add it to the user's clipboard. And so at this point, you realize that it's not really the pasting action that creates the XSS. It's the fact that this document is saved, and when it displays the saved value that you have pasted into the document, it doesn't actually sanitize it properly, and that's when the XSS pops. So it's not just self-XSS, but it's an XSS that is stored and affects all users that view this whiteboard. And that's interesting because for a whiteboard, you can sometimes make it public, you can share it with certain users, and that makes it more publicly accessible. It's not just restricted to a certain set of users. And so the POC itself, I didn't put the full POC here because that would be way too long. But essentially, to speed things up, rather than sending it as a protobuf from the client to the server to save it as a stored XSS, I just use the same kind of client logic to add the HTML payload to my clipboard, and then I would just paste it into the document, and that will create a stored XSS, rather than trying to recreate that whole very complex chain of protobuf communication that you saw earlier. And so for those who regularly maybe hunt on Zoom, you might understand that Zoom has a really strong CSP by default, but that actually varies depending on which tenant you're using or which client they're using. So from web to mobile to desktop, they all use actually slightly different engines that might lead to different vulnerabilities. So at least with the CSPs, there are some ways to bypass it or not. But even then, you can also exploit by jumping from the JavaScript to maybe a sandbox escape if you're using an outdated inbuilt browser, right? So these all gives you opportunities to create a stored XSS over a Zoom call, which is really interesting. So as I mentioned earlier, I hope that you got those three takeaways from this talk. But I also had some final thoughts about finding this bug. The first is that web APIs present an ever-growing attack surface. They are constantly being updated, there are new features always being added to browsers. And back in the day, when you're an Internet Explorer with very proprietary features, that was a fantastic attack surface. Nowadays, we do see more standards, but we also see some proprietary work still being done. And that also presents a very interesting attack surface, because if the implementation is unique to only one browser, there's a higher chance that it might not have been tested as thoroughly as, say, something that's implemented across all browsers. So that's something that you should keep an eye on, especially if you're looking at XSS bypasses or simply looking to find a new exploit. The second is that code scanners can miss vulnerabilities very easily. So as I mentioned earlier, the CodeQL scan didn't actually pick up this vulnerability. And the big reason is because it flowed through the React content editable package, right? And so that's a third-party dependency that wasn't installed in the source code that I was scanning. If I had installed the source code, then maybe it might have picked it up. But for most developers, when they run code scanners in their CI workflow or maybe even their IDE, they might not actually have the third-party dependencies available or accessible in the source code. And that allows you to miss certain things. So as a pen tester, actually, it might make more sense for you to just install the third-party dependencies in the project folder so that the code scanners are able to pick them up and basically run through the entire flow and understand if there's been a vulnerability that occurred to the misuse of a third-party dependency. And this also gives something for developers to think about how they can improve where they place the code scanning job in their CI workflow. And the third is just, regexes, so easy to get wrong. They are confusing, they are complex, and if you miss a single flag like that, then your entire sanitization is bypassed, right? So no, or yes, if you are a pen tester or you're looking for bugs, regexes are always, I think, an interesting place to look, especially if they're being used as a sanitization tool. So as a pen tester, you have to get really good with your regexes to understand exactly, how might a certain flag behave or a certain special character behave in a regex, and this will give you a lot more understanding of exactly how you can exploit something. If you look at my blog, I do have a blog post about exploiting the Amazon AWS simple notification service, and that was also through a regex. So check it out, and you might also learn a bit more about how I can exploit a regex to bypass certain checks. So I hope that you've taken away something useful from this talk. It's a very kind of straightforward discussion of a bug that I found in Zoom, but it also kind of brought out, I think, pretty interesting learning points about how you can improve your bug hunting, how as a researcher there might be interesting things for you to look at, and of course more hands-on bypasses to specific regexes or sanitization workflows. If you enjoyed this talk and you want to learn more, I do have a Twitter that's active, as well as a blog where I often share new blog posts or tips and tricks in cybersecurity, as well as my own cybersecurity research. So check that out, and I look forward to your questions or chats on Twitter. Thank you for listening.